Good morning. Welcome to today's session, Lesson 1.1. What is an AI agent? Imagine a smart assistant that doesn't just answer your questions, but proactively accomplishes tasks for you, like a diligent intern made of code. This is the leap from simple chatbots to true AI agents. These are autonomous systems that can perceive, reason, and act to achieve goals, making them a revolutionary force in technology. Understanding what truly defines an agent is the first step to harnessing their power. 2. Our learning compass, learning objective. By the end of this lesson, you will be able to differentiate an AI agent from other AI systems, like a standard chatbot or automation script, based on its ability to perceive, reason, and act to achieve a goal. 3. What we'll explore. Overview of content. We will define the term AI agent, explore the key characteristics that make them unique, and use a clear example to illustrate the difference between a simple AI model and a fully fledged agent. 4. Content delivery. Now let's move into the core content. An AI agent is a system designed to perceive its digital environment, reason about its observations, and then take independent actions to achieve specific goals. The key differentiators that make an agent unique are perception. An agent takes in information from its environment. This could be a user query, data from a website, an email notification, or sensor data. Reasoning and decision-making. Unlike a script that follows a fixed path, an agent can handle ambiguity, make plans, and decide on the best course of action to achieve its goal. It thinks. Action. This is the critical difference. An agent doesn't just provide an answer, it does something. It uses tools to execute tasks, like booking a flight, running code, or updating a database. Let's look at a clear example. Chatbot versus agent. A standard chatbot might answer the question, "What's the weather in Paris?" by providing a pre-formatted text response. It gives you information. An AI agent, given the goal, "Help me prepare for my trip to Paris," might first check the weather, then suggest appropriate clothing, then check for flight deals, and then ask if you'd like to book a hotel. It takes a series of actions toward a complex goal. 5. Putting knowledge into practice. Interactive engagement. Now that we've laid the theoretical groundwork, it's time to solidify your understanding with a quick activity. Activity. Consider your favorite delivery app. Is the part that suggests restaurants an AI agent, or is it a simpler AI model? Think about its ability to perceive your location, past orders, reason what you might like, and, most importantly, act. Place the order, process payment, dispatch a driver. Justify your answer. Please share your thoughts.
Lesson 1.2, the core components, the AI agent burger. Setting the stage. Welcome back, everyone. In our last session, we defined what an AI agent is. Now, in Lesson 1.2, we're going to look under the hood. Thinking of an agent as a single magical brain is misleading. In reality, it's a system of distinct parts working together perfectly. To make this easy to grasp, we'll use a simple and memorable analogy, the AI agent burger, to deconstruct it into its essential layers. Our learning compass. Our goal for this session is clear. By the end, your learning objective is to be able to identify and explain the 6 core components of an AI agent using the AI agent burger analogy. This framework will give you a mental model you can use to understand any agent you encounter. 3. What we'll explore. To build this understanding, we will first introduce the AI agent burger analogy. Then we will systematically go through each of its 6 layers, detailing what they are and why they are critical. The models, the tools, knowledge and memory, audio and speech, guardrails, and finally the orchestration that holds it all together. Content delivery. Now let's move into the core content and assemble our AI agent burger. Imagine each part is a layer of the burger, essential for the final product. The models, the patty. This is the heart of our burger, the main substance. The model, typically a large language model like Gemini, is the core reasoning engine. It understands language, processes information, and makes decisions. Without the patty, you just have a bun with some toppings. It's not a burger. The tools, the toppings. A burger patty is good, but toppings like cheese, onions, or bacon make it great. Tools are the external capabilities the agent can use to get real-time information, a calculator for math problems, or an API to book a flight. They give the agent skills beyond its core knowledge. Knowledge and memory, the special sauce. This is what gives the burger its unique flavor and consistency. Knowledge and memory allow the agent to recall past interactions and access specific data. This includes remembering your preferences, accessing a company's internal documents, or simply recalling what you said 5 minutes ago in the conversation. It provides context. Audio and speech, the bun. This holds everything together and is how you interact with the burger. This layer represents the user interface. It can be text-based, like a chatbot, but it also includes speech-to-text, hearing your voice, and text-to-speech, speaking back to you, making the interaction natural and seamless. The guardrails, the lettuce wrap. Think of this as the clean, healthy lettuce wrap that keeps everything contained and safe. Guardrails are the safety systems, ethical constraints, and policy filters that ensure the agent behaves appropriately. They prevent it from generating harmful content, going off topic, or violating privacy. Orchestration, the chef's skewer. Finally, a skewer is often pushed through a big burger to hold all the layers together perfectly. Orchestration is the central process that coordinates all the other components. It takes the user's request, decides which tool to use, consults the memory, gets a response from the model, checks it against the guardrails, and delivers it through the speech interface. It's the master coordinator ensuring everything works in harmony. So there you have it, the complete AI agent burger from the reasoning Hattie to the coordinating skewer. V. Putting knowledge into practice. Interactive engagement. Now that we've laid the theoretical groundwork, it's time to solidify your understanding. For your interactive engagement, I'd like you to work on the following prompt. Think of a simple AI agent whose goal is to tell me a summary of today's top news story. Go through each layer of the AI agent burger and describe what role that component would play in accomplishing this simple task. For example, what would be its primary tool? What guardrail might be important? This exercise is designed to help you solidify your understanding of how these theoretical components function in a practical, real-world task. Please share your breakdown.
Lesson 2.1, Prompt Engineering, the Art of Instruction. I. Setting the stage, context and relevance. Communicating with an AI agent is a skill. Just as you would give a human assistant clear, specific instructions to get a task done right, you must do the same for an agent. A vague request leads to a vague result. This art and science of crafting effective instructions is called prompt engineering. It's the difference between getting a masterpiece and a mess. I. Our learning compass, learning objective. Our goal today is to define prompt engineering and construct a well-crafted prompt for a given task that is clear, specific, and provides sufficient context. I. What we'll explore. Overview of content. Today, we will define prompt engineering, discuss the key principles of writing effective prompts, clarity, specificity, and context, and work through an example of refining a poor prompt into a good one. V. Content delivery. Now let's move into the core content. What is prompt engineering? It is the practice of designing and refining input text, the prompt, to guide an AI model or agent toward a desired output or action. Think of it as the most direct and powerful way to control an agent's behavior. Next, we'll look at the core principles that make a prompt effective. Principles of effective prompts. Be specific. Don't say, "write about cars." That could mean anything. Instead, say, write a 100-word summary comparing the fuel efficiency of a 2024 Honda Civic and a 2024 Toyota Corolla. See how much clearer that is. Provide context. Give the agent the background information it needs to succeed. Instead of just summarize this, you should say, you are a financial analyst. Summarize the attached earnings report for a non-expert audience, focusing on the key growth drivers. This gives the AI a role and a purpose. Define the format. Tell the agent how you want the output. For example, provide the answer in a JSON format or list the key points using bullet points. Let's look at a clear example of moving from a vague prompt to a valuable one. Poor prompt. Help me with my trip. Good prompt. I am planning a 3-day weekend trip to San Francisco next month. I am on a budget of $500. Please suggest a travel itinerary that includes 2 free museums and a recommendation for a highly rated pizza place near Fisherman's Wharf. The good prompt provides the destination, duration, budget, and specific interests, allowing the AI to generate a truly helpful response. V. Putting knowledge into practice. Interactive engagement. Now that we've laid the theoretical groundwork, it's time to solidify your understanding. You have an AI agent that can write emails. Your task is to get it to write an email to your boss requesting a day off. Write down the prompt you would use. Think about what specific information your prompt needs to include for the agent to succeed. Please share your prompt when you are ready.
Lesson 2.2, Context Engineering and Retrieval Augmented Generation, RAG. To get us started, think about this. While a good prompt is essential, advanced AI agents need more than just the initial instruction. They need access to a deep pool of relevant information to perform complex tasks. This is context engineering, proactively giving the agent all the data it needs to succeed. The most powerful technique for this is Retrieval Augmented Generation, RAG, which we'll be focusing on today. Our learning compass. By the end of this lesson, you will be able to explain how Retrieval Augmented Generation, RAG, enhances an agent's performance by providing dynamic external context. What we'll explore. Today, we will define context engineering, introduce the concept of RAG, and explain the step-by-step process of how an agent uses RAG to answer a question with information it wasn't originally trained on. 4. Content delivery. Now, let's move into the core content. First, what is context engineering? It is the process of designing systems that provide an AI agent with all the necessary information, the context, to perform a task. This goes beyond the initial prompt and involves connecting the agent to external knowledge sources. The core technique for this is Retrieval Augmented Generation, RAG, which we'll be focusing on today. So how does it actually work? Let's break down the simplified process. User question. The user asks a question, like, what was our company's revenue in Q2? Retrieval. The system doesn't immediately ask the LLM. First, it searches a private knowledge base, for example, a database of company financial reports, for documents relevant to Q2 revenue. Augmentation. The relevant information it finds, the context, is added to the original user question. The prompt becomes much more powerful. Context. Here is the text from the Q2 financial report. Question. What was our company's revenue in Q2? Generation. Finally, this combined, augmented prompt is sent to the LLM. The model now has the exact facts it needs to generate a precise and accurate answer. 5. Putting knowledge into practice. Interactive engagement. Now that we've laid the theoretical groundwork, it's time to solidify your understanding with a practical scenario. Imagine you are building a customer support agent for an e-commerce website. A customer asks, where is my order 12345? What external knowledge base would the agent need to retrieve information from using RAG to answer this question accurately?
Lesson 3.1, The Iterative Evaluation Loop. Part 1, Setting the Stage, Context and Relevance. Building a high-quality AI agent is not a one-shot process. Think of it like a chef perfecting a new recipe. They don't just mix ingredients once and serve it at the restaurant. They cook a small batch, build, taste it, test, notice it might need more salt or less cooking time, get feedback, and then adjust the recipe, refine. This cycle continues until the dish is perfect. Similarly, no AI agent is perfect on its first try. Understanding and embracing this iterative process, known as the eval loop, is fundamental to creating robust and reliable agents that truly work. Part 2, Our Learning Compass, Learning Objective. By the end of this session, you will be able to describe the eval loop as an iterative process for improving an AI agent's performance. Part 3, What we'll explore, Overview of content. Today, we will define what the eval loop is and then break it down into its 5 core stages: building a prototype, generating test cases, evaluating outputs, analyzing failures, and refining the agent. Part 4, Content Delivery. Now, let's move into the core content. The eval loop is the cyclical, iterative process of testing an AI agent against a set of standards, analyzing its failures, and making improvements. It's a structured way to make your agent better and better over time. Let's look at the stages of this loop. Build/modify. You start with your initial agent configuration. This includes the AI model you're using, any tools it can access like a calculator or a search engine, and the initial prompt that tells it how to behave. Generate test cases. Next, you create a dataset of inputs and the expected correct outcomes. This is your exam for the agent. These test cases can range from simple questions like, "What is the capital of France?" to complex multi-step tasks like, "Find the top 3 reviewed Italian restaurants near me and book a table for 2 at 7 p.m. tomorrow." Evaluate performance. Now you run your agent against the test cases and measure how well it does. Did it succeed? Did it fail? Perhaps the answer was factually correct, but delivered in the wrong format. You log all of these results. Analyze failures. This is the most crucial step. You must become a detective and dig into why the agent failed. Was your prompt unclear? Did the agent choose the wrong tool for the job? If it's a research agent, did its system pull the wrong document to get the answer? Pinpointing the root cause is key. Refine and repeat. Based on your analysis, you modify the agent. You might tweak the prompt for more clarity, improve how a tool works, or add rules, guardrails, to prevent it from making the same mistake. Then, you run the entire evaluation loop again with your improved agent to see if the changes worked and if they introduced any new problems. This cycle repeats until the agent meets your quality standards. Part 5, Putting Knowledge into Practice, Interactive Engagement. Now that we've laid the theoretical groundwork, it's time to solidify your understanding with a quick scenario. Imagine you've built an agent designed to summarize news articles. In your first test, you give it an article about a major sports game. You expect a summary of the game's score and key plays. Instead, the agent gives you a summary of the team's recent financial performance. Walking through the eval loop, you've just completed the evaluate performance stage and found a failure. What is your very next step, and what might you investigate?
Lesson 3.2, Methods of Evaluation. We already understand the importance of the eval loop. Now we need to know how to actually measure performance. Imagine trying to judge a chef's skill. You wouldn't just taste one single bite of one dish, would you? Of course not. You'd want to look at their knife skills, their ability to combine flavors, the presentation of the plate, and maybe even how clean they keep their kitchen. Similarly, there isn't a single score for an AI agent. We need a toolbox of different evaluation methods, from automated checks to the gold standard of human judgment, to get a complete and accurate picture of an agent's quality. By the end of this session, you will be able to identify and compare the three primary methods for evaluating an AI agent's performance: LLM as a judge, rule-based evals, and human evals. Today, we will detail the three main techniques for agent evaluation, discussing the pros and cons of each: LLM as a judge for scale, rule-based evals for precision, and human evals for nuance. Now, let's move into the core content. There are three main ways to evaluate an agent's output during the eval loop. 1. LLM as a judge. How it works? You use another powerful LLM, like GPT-4 or Gemini, to evaluate your agent's response. You provide it with the initial prompt, the agent's output, a model answer if you have one, and a clear rubric. The judge LLM then scores the output based on that rubric. Pros: it's very fast and can be scaled to run thousands of tests automatically. Cons: it can be expensive to run many calls to a powerful model, it may have its own biases, and it can struggle with highly nuanced or subjective tasks where human experience is key. Number 2. Rule-based evals. How it works? You write code to programmatically check for specific objective criteria. For example, does the output contain a URL? Is the JSON in the output valid? Or is the word count below 200 words? Pros: this method is extremely fast, cheap, and highly reliable for checking specific constraints. Cons: it's brittle. It cannot measure the semantic quality or goodness of a response, only its structure or the presence or absence of specific keywords. And 3. Human evals, the gold standard. How it works? Real people interact with the agent or review its outputs and provide ratings based on a clear rubric. They might score the responses for things like relevance, safety, tone, and factual accuracy. Pros: this is the most accurate way to measure nuanced quality and the true user experience. It's the only way to really know if a response feels right. Cons: it is slow, very expensive, and not scalable for the kind of day-to-day regression testing needed in rapid development cycles. Now, let's put knowledge into practice. Activity. You are evaluating an agent designed to provide medical advice. Which of the three evaluation methods would you trust the most for ensuring factual accuracy and safety? Which would you use for quickly checking if the response is always formatted correctly? Explain your choices.
Lesson 4.1: The Agent Builder's Toolkit. Understanding the theory of AI agents is one thing, building them is another. Fortunately, a rich ecosystem of tools has emerged to help creators at every skill level, from professional developers to business users with no coding experience. Knowing the landscape of these tools is key to choosing the right one for your project. 2. Our learning compass, learning objective. By the end of this lesson, you will be able to differentiate between code-based, low-code, and no-code platforms for building AI agents. 3. What we'll explore. Overview of content. Today, we will categorize and provide examples of the three main types of tools used to build AI agents: powerful code-based frameworks, flexible low-code platforms, and accessible no-code interfaces. 4. Content delivery. Now let's move into the core content. When you decide to build an AI agent, you'll encounter a spectrum of tools. We can group them into two primary categories. First, we have code-based frameworks. Description. These are primarily Python libraries that provide the essential building blocks like orchestration, tool integrations, and memory modules for developers to construct sophisticated and highly customized agents from the ground up. Examples. Popular frameworks you'll hear about include LangChain and Llama Index. Best for. These are ideal for creating complex, bespoke agentic systems that demand maximum control and flexibility. Think of a unique, public-facing product where every detail matters. Next, we'll look at low-code, no-code platforms. Description.
These are visual platforms that allow you to build and deploy agents by connecting pre-made blocks in a graphical interface, often with little to no coding required. They expertly abstract away the underlying complexity. Examples, tools like Retool, Microsoft Copilot Studio, and Zapier fall into this category. Best for, these are fantastic for rapid prototyping, building internal tools for a company, and automating business workflows without needing a dedicated development team. So how do you choose the right tool? The choice depends entirely on your goal and technical skill. For maximum power and customization, you would use a code-based framework. For speed, accessibility, and automating internal tasks, you would turn to a low-code or no-code platform. 5. Putting knowledge into practice, interactive engagement. Now that we've laid the theoretical groundwork, it's time to solidify your understanding with a practical scenario. Activity. A small marketing team wants to build an agent that automatically generates social media posts from their blog articles. They have no developers on the team. Which category of tool would you recommend they explore, and why?
Lesson 4.2: Advanced Concepts and the Future of Agents. We have covered the foundations of building and evaluating a single AI agent, but the field is rapidly advancing. To complete your foundational knowledge, it's important to be aware of the horizon, the advanced concepts that are defining the next generation of agentic AI. Our learning compass for today is to define two advanced AI agent concepts: multi-agent systems and responsible AI ethics. To achieve this, we will provide a high-level introduction to two key areas of future development: multi-agent systems, where agents collaborate, and the crucial field of responsible AI, which ensures these powerful tools are built safely and fairly. Now, let's move into the core content. First, we'll look at multi-agent systems. The core concept here is that instead of one agent trying to do everything, you create a team of specialized agents that collaborate to solve a complex problem. For example, imagine a research team of agents. A chief researcher agent receives the main goal. It delegates the task of finding sources to a search agent. The search agent passes the sources to a summarizer agent. Finally, a writer agent compiles the summaries into a final report. This division of labor allows for more complex and robust problem solving. Next, we'll look at responsible AI and ethics. This is a critical field focused on ensuring that AI agents are developed and used in a way that is safe, fair, transparent, and accountable. It's not just a technical problem, but a societal one. This forces us to ask key questions. How do we prevent agents from causing harm? How do we eliminate bias from their decision-making? Who is accountable when an agent makes a mistake? How do we make their reasoning understandable? This is also called transparency. Building powerful tools comes with the profound responsibility to build them ethically. Now that we've laid the theoretical groundwork, it's time to solidify your understanding. Activity. Let's brainstorm a complex task. For example, launch a new product. How could you break this down for a multi-agent system? What specialized roles might different agents play? Think about roles like a market research agent, a branding agent, or a project manager agent. Take a moment to think and share your ideas. I'll wait for your response.
Conclusion of course. Introduction to AI agents. You have now completed the full master course. You have progressed from defining a single agent to understanding its components, methods of communication, evaluation techniques, and the tools used to build them, concluding with a view of the future. You are now equipped with the foundational knowledge to begin your hands-on journey into building and experimenting with AI agents. The landscape of AI agents in 2025. The world of AI agents is no longer a theoretical concept. It's a rapidly expanding reality. In 2025, AI agents are increasingly autonomous, capable of perceiving their environment, making complex decisions, and executing tasks with minimal human intervention. This evolution is transforming industries by enhancing productivity and operational efficiency. Key advancements in machine learning and natural language processing are at the heart of this transformation, enabling agents to be more adaptive and versatile. They are being deployed in a wide array of sectors: healthcare, assisting in patient monitoring and analyzing medical records; finance, powering automated trading, conducting risk assessments, and detecting fraud; customer service, handling complex support tickets and providing 24/7 assistance; software development, writing, refactoring, and debugging code. The future of AI agents, what to expect. The trajectory of AI agents points toward even greater autonomy and integration into our daily lives and work. Several key trends are shaping this future. Multi-agent systems. The focus is shifting from single-agent applications to complex, collaborative systems where multiple agents work together to solve problems. This orchestra approach allows for specialized agents to handle different aspects of a task, leading to more robust and efficient outcomes. Hyper-personalization. AI agents will increasingly offer experiences and services tailored to individual needs and preferences by retaining memory of past interactions. Human-agent collaboration. We will see a deeper integration of AI agents into human teams where they act as digital workers or virtual assistants, augmenting human capabilities. Increased focus on ethics, safety, and alignment. As agents become more autonomous, ensuring they operate safely, ethically, and in alignment with human values is a critical area of research and development. This includes developing transparent and explainable AI, XAI, and establishing robust governance frameworks. Your journey into AI agent development. With the foundational knowledge from this course, you are now ready to dive into the practical world of building AI agents. Here are some resources to help you get started. Beginner-friendly frameworks and tools. LangChain, a widely adopted and powerful framework for building applications with large language models, offering a modular structure for creating agents. AutoGen from Microsoft, a framework that focuses on creating multi-agent conversational systems where agents can talk to each other to complete tasks. Crew AI, designed for orchestrating role-playing autonomous AI agents, making it easier to prototype multi-agent systems. Microsoft's AI Agents for Beginners course, a free 11-lesson course that takes you from concept to code, covering the fundamentals of building AI agents. Open source projects to explore. There are numerous open source projects available on platforms like GitHub that you can contribute to or use as inspiration. A curated list of over 500 AI agent projects showcases a wide range of applications across different industries. Project Pro offers a list of AI agent projects with source code for beginners, covering use cases like cryptocurrency analysis and customer support bots. Join the community. OpenAI Developer Community, a forum for developers using OpenAI's tools and APIs to ask questions and share knowledge. Kaggle, a large community of data scientists and machine learning enthusiasts with datasets and competitions to hone your skills. Discord and Reddit. There are various private and public groups on platforms like Discord and Reddit, like r/AI agents, where you can connect with other developers, discuss new techniques, and collaborate on projects. Global AI Community. This organization connects AI communities worldwide and hosts events and conferences, including AgentCon 2025, an AI Agents Developers Conference. The field of AI agents is one of the most exciting and rapidly evolving areas in technology. By completing this course, you have taken the first step into a larger world of innovation. Continue to be curious, keep learning, and start building. The future of AI is not just something to be observed, but something you can now actively shape.